Alright, so here is a Half-Life problem, and there are generally two ways to do this. We're going to use the chart method, which only works on some type, but will, for most of your classes, work. So the way you do the chart is you make three columns: Half-Life, time, and amount. And always these columns. And the other thing you can always do is set your half-life to 0 and 0 to begin with. Everything's going to start with 0 times 0 half-lives. So we're starting with 80 grams of this, so I'm going to write 80 grams under the amount. And now we're just going to try to figure out the half-life is 10 years, so every 10 years is going to cut in half, and we want to know how much it'll be after 40 years. So we're going to just fill down this chart. So we're going to say, okay, one half-life later, well, if a half-life is 10 years, that will be 10 years later. And the definition of a half-life now will have 40 grams. And then another half-life later, which will be the second half-life, 10 more years, it'll be 20 years. We cut 40 in half because, again, that's what a half-life is, so we're at 20 grams. And the third half-life will be another 10 years later, 30 years. Don't make the mistake of doubling the 20. That's a common thing. So just add 10 more years. So another half-life's 10 grams. And lastly, in the fourth half-life, 10 more years later, we're at 40 years, which is what we were asked about. We'll have 5 grams remaining. And the important thing is make sure you answer the question like we wanted to know this, so I'll circle that as my answer. So after 40 years, I'll have 5 grams left of my material. And that's it. So until next time, I am Derek Genova. Have a delightful day.